So if we go back to what we did last time in here for practice, was there anything in Chapter 7's material that you still wanted to go over? We're trying to keep everything in order if we possibly can. Kind of hopped around in 7 last time when we reviewed. There is the integrity recording of the last stuff that we went over, so if you need, you can go back to that and take a look at it. Yes?
It's not in there.
It's not? Oh, okay. Let me do another double check. I swear I put it in there. Okay, I'll check. What was that?
I watched the review for the integrity.
You watched the what?
No, the review.
No, the integrity's in there, but for 5 points is the
I'll take all the points I can get.
I don't know why it's not in there. I'll have to go back and make sure that maybe I didn't put. I thought I put everybody's in there, but we'll see. I'll let this thing come up so you can see if I'm writing anything. Okay, anything in Chapter 7? Chapter 7's good?
No, number 6.
Which one?
Number 6.
6. Okay. Number 6. So if we put number 6 up here, number 6 happens to be that big long thing. So we've got a multiplication in the middle. So that means that we need to take everything that we have in here, and I'm going to rewrite it on here so we can see it a little bit larger than what's there. And we need to take all of those and factor them. So if I take the very first one, I can't just break it apart just like it is because it's got that 2 out in front. So 2x squared times a negative 15 is a negative 30x squared. So I need things that multiply to give me 30x, but add to give me a negative 7. What will they be? 10 and 3, right? It's 10x times negative 10x times positive 3x gives me this, and a negative 10x plus 7x will give me, or plus 3x, sorry, will give me my 7x in the center. Replace my middle, 2x squared minus 10x plus 3x minus 15. Group in my 2's, and so I can pull out a 2x out of the first. Leaves me with x minus 5. Second one, I can pull out a positive 3. Leaves me with x minus 5. They both match, so I must have factored correctly. So this thing factors to 2x plus 3 times x minus 5. So 2x plus 3 times x minus 5. I do not have to factor that bottom, so x plus 2 just comes along. I don't have to do anything with it. The next one, I can factor that because it's got a single x squared out in front, so I have an x and an x. So factors of 4 that add to 4. What would I have?
2 and 2.
Yep, 2 and 2. Let me get up here a little bit more. So I have x plus 2 and x plus 2. Then I got another one of them long things on the bottom. So 2x squared times 6 is 12x squared. So things that multiply, but at the same time add to give me a 7x in the middle. So what would I end up with? Well, it looks like 3 and 4, 3x and 4x. Replace my middle, so 2x squared plus 3x plus 4x plus 6. Group in 2's. What do I pull out of that first part? I pull out a x only. Leaves me with 2x plus 3. Second one, I can pull out a plus 2. Leaves me with 2x plus 3. And so it factors to 2x plus 3 and x plus 2. So I need to see what row can I cancel. Well, 2x plus 3's cancel. We okay so far? Okay. 2x, or x plus 2 and x plus 2 cancels. Another x plus 2 and another x plus 2 cancels. So the only thing this whole problem has left in it is x minus 5. Okay? So that's the only piece that's in there. So you get x minus 5. All right. Anything else in chapter 7? 12? Okay. So let's see. Flip the page here for that one. Number 12 is a complex fraction. So I'm going to need more room on my paper for that one, so I'm going to flip it over here. And let's write it, oops, let's write it on here first. So number 12 is 4 over x minus 8 over x squared all over 3 over x minus 12 over x cubed. So that's my problem. So now what I need to do with it is find common denominator. We did these two ways. Last time I did just the top part and we come up with the common denominator and we did it out, and then we did the bottom with its common denominator. This time around I think what I'm going to do is clear out all of those denominators. Alright? So what that means is everybody in here, since x cubed is my common denominator between all of them, what would I have? Well, x and x cubed will cancel the x out, leaving me an x squared. So I have 4x squared. X squared and x cubed leaves me with an 8, or with an x, leaves me 8x. Since I've canceled those denominators out here, I no longer have them. I've removed them. Then I want to do the same thing down here. X and x squared leaves me with an x squared, so I have 3x squared. And x cubed and x cubed gives me just a plain old straight negative 12 once I've removed them. And then I can factor out a 4 out of the top part, leaves me with, and an x, sorry. So I can factor out a 4x out of the first one, leaves me with x minus 2. And in the bottom, I can factor out a 3, and that leaves me with x squared minus 4, but x squared minus 4 is factorable besides. So I have 4x on x minus 2. The bottom, I have 3 times x minus 2 and x plus 2. So then I want to see what cancels. So does anything cancel? Yep, x minus 2's cancel. So I'm left with 4x over 3 times x plus 2. Does that make sense?
Now, do you want us to factor or to distribute that?
No, we don't need to. You are fine with what comes out right there. Okay? So that's there. All right, that was 12. Any other ones in here? In chapter 7. Okay? Chapter 8. Number 20. I thought we did 20. Didn't we do 20 the other day?
I'll look at it.
I think we did. I think you can find that one because I've got written in ink in here. Because what you find out with number 20 is your two lines are exactly the same. Okay? When you get rid of these denominators, you come up with exactly the same line. And so when you write this out into your box, they will be the exact same numbers. And because they're on top of each other, it's an infinite solution.
Okay.
Yep. Okay. Anything else in chapter 8? 22, sure. 22 has the fractional value, so let's get these written out here because we got to come up with what the equations are going to be. Negative 4/3 x minus 4/3 y equals a negative 2. And negative 8/3 x minus 8/3 y equals 4/3. So I'm going to get rid of my denominators, so I'm going to do that with this top one. That means I have to multiply everything by 3. So these cancel, leaves me with negative 4x. Those cancel, leaves me with minus 4y. And 3 times a negative 2 is a negative 6. And to finish it, because I need to get it in a y equals situation right here, so I need to solve for y in here. So I'm going to minus 4x from both sides. Oh, add it. Thank you. Yep. Thank you, thank you, thank you. And so I get a negative 4y is equal to 4x minus 6. Divide by negative 4. And I find y is equal to a negative x minus 3, or plus 3 halves when you reduce that, because 2 will go into 6 3, and 2 goes into 4 twice. So that's what it comes down to. Do the same thing with the second one. And so the 3's cancel, leaves me negative 8x minus 8y is equal to 4. Same thing, add 8x gives me a negative 8y is equal to 8x plus 4. Divide by a negative 8. And I find y is equal to a negative x plus 1/2. No, minus 1/2 with my signs. Okay, so that fills this piece in. So I have negative 1, and I have 3 halves. And in the bottom one, I have a negative 1, and I have negative 1/2. So when I graph that, what do you think is going to happen? If I plot it in there, what's going to happen to those two? They're what? Parallel. Yep. They're going to be parallel to each other. And so if I graph the first one, I'm up at 3 halves. So 1 3/2. Slope says go down 1 and over 1. So the first line is going to look like so. The second line is down at a half. Slope still says go down 1 and over 1. So it's going to come in like so. And the two end up being parallel to each other. So what do I know about my solutions? No solution. Yep, because they don't cross each other. Okay? Good. That was a good one to review, so you get the idea of what happens with those. Again, it's the graphing part of that. Anything else in Chapter 8? Went over matrices last time, so I think you're probably okay with that part, hopefully. If not, now's time to ask. Those Chapter 8, we consider it good, or we don't consider it good? What are you thinking? Which one? 28. All of that? Okay, 28. I think we did that one last time, if I remember right, didn't we? Or we set it up, we didn't finish it. Okay, 28. 28, last time we set it up to be the sum of two numbers is 42, so x plus y equals 42. And then it says the sum of the smaller and 4 times the larger, so we're going to make x the smaller. So the sum of the smaller plus 4 times the larger is going to equal 147. Okay? All right. So now I would probably use on this one elimination or addition, because I can change the sign real easily on that one. So negative x minus y minus 42, and x plus 4y equals 147. And if I take these, x's disappear, the y's become 3y, and 42 from 47 leaves me with 105. Divide by 3, and I find y is equal to 3 goes into 10 3 times, 3 goes into 15 5, y equals 35. Okay?
I just put it in a matrix state and got the answer.
Yeah. Yeah, you can do it that way too. What's wrong with this one? Did I do something wrong mathematically?
No, just do do the 3 by 5 or 3 by 2.
2 by 3. A 2 by 3. Yeah. And so then if I plug 35 back in here, I have x plus 35 equals 42. Subtract 35. And I find good old x. These 35s are gone. Good old x is equal to 7. Okay? Yeah. And you can do it on your calculator with a 2 by 3 matrix. Okay? I think we set that one up as letter A in your calculator, if I remember right, when we did that before. So that one is what you have with that one. 29, I think we also set that one up. I think you're okay there, right? 30, we set that one up. We did 27. 31? We did not do 31, so let me get 31 up here so we can see what it looks like. It says the sum of two integers is 83. So that means I have x plus y equals 83. And then it says, and the larger integer is, so we're going to make y our larger integer, is always means equals 14 more than 2 times the smaller. So 2x plus 14 will be my 2 equations. We okay with that part? Yes? Okay. So then this one I'd probably use substitution because I can just put this in place of y. So I have x plus 2x plus 14 is equal to 83. X plus 2x is 3x minus 14. I find that 83 minus 14 is 69. Divide by 3. I find x is equal to 23. Okay with that part? Okay. To find y is equal to 2 times 23 plus 14. So 2 times 23 is 46. 46 plus 14 is 60. How does it work? 60 plus 23 does equal 83. So I know I've got my correct solutions. So you can always check those. Those story problems can work your way back with those and come up with what their answer is. All right, so that was 31. Anything else? Well, it's a good thing I didn't just say, oh, looks like you have any questions on 8, because I'm getting them. Are you all right with 34? We did one like that, I thought, didn't we?
We did 34.
Oh, we did 34? Okay. I just didn't have anything written in my sheet here. And then we also set up 35, I think. I don't think I solved it, but I think I left that for you to do. Okay, anything else? Chapter 8. Oh, we're moving on to chapter 8, chapter 9?
Oh, I'm sorry.
Oh, that's okay. Oh, if we're ready, we can, move on to chapter 9. Are we ready to move on to chapter 9? Yes? Okay, 44 you said?
Yeah.
Okay. 44 is one that has rational things we got to solve. So let me write that up here. 44 is the cube root of 8x to the 14th y to the 23rd plus the cube root of x to the 14th y to the 23rd minus the cube root of 8x to the 13th y to the 5th. So what I have to do with these is I have to see if I can pull some stuff out of them. Well, 8 is the perfect cube of what? 2. So let me get my radical in here. X to the 14th, I got to see how many times 3 goes into 14. How many times 3 go into 14? 4. So I pull out an x to the 4th, but leave an x to the what under the radical? The 2nd. Then I look at 3 goes into 23. Y to the 7th, because 3 times 7 is 21. From 23 leaves me a y squared under my radical. You okay so far? Okay. Continuing. X to the 14th. 3 goes into 14 4 times. So x to the 4th but it still leaves under my radical an x squared. 3 goes into 23, 7. And that leaves a y squared underneath my radical. And last, take out the 8, so that's a 2. 3 goes into 13 4 times, leaves me with x to the 4th, but leaves an x under my radical. 3 goes into 5 twice, or once I should say, brings out a y, but leaves a y squared under my radical. So now I got to go back and look at this and say, can I put any of this together? Now to put it together, what has to happen? Everything here has to match, and everything under here has to match, okay? So if I look at this one, does this one match anything? No, but these two match each other. Notice it's x to the 4th, y to the 7th, x squared and y squared under the radical still. So I can add these together. There's a 1 there, so I really have 3x to the 4th, y to the 7th, the cube root of x squared, y squared. This piece can't be added to anything, so it just comes down and is left there. And so that becomes my answer. So that's what I have here. Okay? Makes sense now? Hopefully. Okay. Anything else in chapter 9? Good with chapter 9? Yeah? Okay. Now the new stuff. That was all the review stuff from last time, and I said we'd pick up whatever we had. So in this one, and we're going to put chapter 9 up here.
In chapter 9, you can do 49.
Sure. 49. Before we go on to chapter 10. What was that? Oh. I'm not moving it. 49, it says solve the following radical equation, or if there is no solution, write no solution. So in 49, we have the square root of a -1 minus 6v is equal to the square root of a -4v plus 5. Well, when you have radicals on both sides, how do we get rid of them? Square them. So I'm going to take this side and square it, and I'm going to take that side and square it, and the only thing that happens is the radical disappears. Okay? Now I got to get all my v's together in my numbers, so I can add 6v to both sides, subtract 5, and I get a -6 is equal to 2v, divide by 2, and 6 divided by 2 is a -3, equals v. Now, I need to be really careful with this because what can I never have under my radicals? Even though I come up with an answer sometimes, I have to go back and make sure it doesn't give me a negative under here. So -6 times a -3 is positive 18. Positive 18 minus 1 is a positive 17, so I'm good. Over here, -4 times a -3 is a positive 12, and a positive 12 plus 5 is still good, so I can still get the square root of 17. So -3 would be my answer, right? But if that would make any of this stuff come out negative, then I can't use it. So keep that in mind sometimes with those. Again, be careful with what you have. All right, anything else in chapter 9? Okay. Now, chapter 10? Okay. Chapter 10. And this one, we need to just go through some stuff here. So let's look at 55 so that we get a good review of stuff. In 55, it says, a sheet of paper up here, it says solve the quadratic equation by using the definition of square root and write the solution in radical form. Simplify the solution. So if I use my square root thing, I have a square on this side and I have 48 over there. So my square root value is to take each side and take the square root of both sides. So that's what I'd have to do to get this thing solved. So I get 7x plus 5 on the left. And what does 48 break down to? And we need a plus or minus because it could go either direction. 4, the square root of 3. You all agree? Do I need to break it down for you, or are you all right? You're good? Okay. Because 48 is 16 times 3. 16 is perfect square, so I pull out 4. Then I need to finish the rest of it, so I'm going to minus 5. So I have 7x is equal to a negative 5 plus or minus 4, the square root of 3. And last, divide everybody by 7. So I find x is a negative 5 plus 4, the square root of 3 over 7, or a negative 5 minus 4, the square root of 3 all over 7. Because remember, you had to do both routes. Yes?
Now, on our final, can we just put like the plus and the minus over each other?
Yes. Yes. Yeah, on your final exam, you can write just like that and be done with the whole thing, right? It's just that in Hawks, of course, they broke things apart, so you had to have 2 pieces in there for that one. Okay, so 55, we're good. I think you can do 56, correct? 56, just like 55. So is 57. So we're good there. This one, 58. It says solve the quadratic equation by completing the square and simplify the solution and rationalize the denominators. All right, so on 58, I'll write it down here. Well, I guess I can write it down here. 58 is x squared plus 3x minus 14 is equal to 0, so I'll do that with it. So we got to complete the square, so that means I need to get this stuff by itself and you get the 14 on the other side, so minus, or add 14. So now I have x squared plus 3x equals 14. But to complete the square, I need half of 3. So I have x plus 3 halves squared. Then square the 3 halves and add it to both sides. So 3 halves times 3 halves is 9 fourths. So I'm going to add 9 fourths to both sides. And so turn my 14 into fourths. Oh, let's 14 into fourths. 4 times 14 is 56. 56 plus 9 is 65 fourths. We all okay with that part? Okay. Then, in order to get it finished, I need to take the square root of each side. So when I do that, I get x plus 3 halves is equal to the square root of 65 over 2, plus or minus, because I ended up doing the square root stuff with that, because my denominator was perfect square. So I can come up with 2, move my 3 halves over. So x is equal to a negative 3 halves plus or minus the square root of 65 over 2, or if you're in Hawks, it's a negative 3 plus the square root of 65 all over 2, or negative 3 minus the square root of 65 over 2. And that would be my 2 answers. 58. We good?
Did you take the original version or
The original version.
just plus or minus?
Oh, yeah, this part on your test. But you want to put this so it's all over one single 2, not having double 2s underneath it. Yep. Okay, so that was 58. Think you can do 59 on your own? Yes? No? Maybe? Well, we'll leave it. And again, if you got questions next time, when right before you do your exam in here, we can go over some questions that you might have. And in the online group, they can ship me questions on in their discussion. Okay, 60. 60 says solve the quadratic equation by completing the square. So that's another completing the square. We got to do some reversing in here. You need to move the 10x over and move the 22 to the opposite side, but I think you're good there. 61 says solve the following quadratic equation using the quadratic formula. Good there? What is the quadratic formula? What do we have for that formula? Negative b,
plus or minus,
plus or minus,
square root,
uh-huh,
b squared,
b squared,
minus 4ac,
yep,
all over 2a.
all over 2a. Great help, right? So make sure that you have that so that you know what that is, because that'll help you out with your equations as you're working through those. Okay, so I think you're good on 61, 62, correct? And probably 63, because 63 basically is saying use the discriminant, which is the stuff under here, to determine what you have with that following value in there. We good with that one or not? Okay. Now, if it has, so you're going to end up giving that whole equation stuff when you get that work through. Consider, then 64, consider the equation of y equals 2 times x minus 4 squared. Determine whether the graph of the equation opens upward or downward. What told us that in 64? What would tell us if the graph's opening upward or downward? What part? What was that? Upward? How do we know? What was that? The 2, yeah. This 2 is positive. So the 2 is going to tell me it's going to point, it's going to be a upward parabola. And so it's going to face upward. Determine whether the graph of the equation is narrower than this graph. Is it narrower or wider? Which one? Narrower, right. Because this is a 2 and this is a third. Remember, fractions make it narrower, or no, fractions make it wider, sorry. And whole values make it wider. So it's going to be, or narrower, I should say. So it's going to be narrower than that. And then it says, first step, it says graph this parabola. Now, when you get to your final exam will have this equation part, and you're going to be asked to put it on graph paper. Well, how we do that, what did this 4 tell me? Which way? Go down 4? Nope. If you went down 4, what you would have needed, let's just go through what we had here. Y equals a x minus h squared plus k. K tells us the up and down, okay? H tells us to move the opposite of what h is on the x-axis down here. So if I were to graph this one would tell me I'm over 4 this way. Okay, I'm over 4. And you would just randomly figure out, whoops, narrower, not wider, narrower. Get my graph in here like it's supposed to be. So it should be narrower than the other ones. Yep. And it's going through the vertex of 0, 4. So, and then it says find the point for B when it's at 5, or find the point A when it's at 2. So if I plug 2 in here, 2 minus 4 is a negative 2. Negative 2 squared is a positive 4. Positive 4 times 2 is 8. And then to find the other point, if I put 5 in where x is at, 5 minus 4 is 1. 1 times 1 is 1, times 2 is 2. And so you would end up finding both of those points on here. So when I'm at 2, I'm up at 8. When I am at 5, I'm supposed to be up at 2. I'm a little bit off there, but so that's what you do with that one. Okay, make sense? Okay. See if we've got one in here that's got the, this. The next one has H in it. So on your test, your exam, you will be given an equation and you'll be asked to just graph it. So if I graph this one, the negative 4 means I'm going to be down 4, and I am going to go a negative 4 over. 1, 2, 3, 4. So my vertex would be at that location. The value in front is a 1, so it's just kind of basically a normal graph. And so it would just be a parabola that's going to go and do one of these numbers. But I need to finish it on here so it looks right. So is it going to be upward or downward? Upward, because the 1 in front is positive. Is it going to be wider or narrower than a third? Narrower. Okay. And if I plug in a -6 times, or -6 plus 4 is a -2, squared is a positive 4, times 1 is 4, 4 minus 4 is 0. And then if I plug in my other point, -3, -3 plus 4 is a positive 1. 1 times 1 is 1, times 1 is 1. 1 minus 4 is a -3. So if I plot these 2 points, -6, I'm at 0. -3, I am at a -3. So this parabola is kind of doing one of these numbers. So that's what my parabola would end up looking like. All right. So just keep in mind your A's, H's, and K's. H's go opposite. All right. What tells me my vertex? Well, my vertex is opposite of H and whatever K is. All right. So that's my vertex. So if you're asked for that, yes.
Where did you get your -3?
Where did I get my -3?
I know where you got it, but
Where did I put it? Right here.
then why did the parabola be all the way at -1?
Why is it over here? Because if you look at -3 down 3 is right here, okay? And I might be off because my line of symmetry is coming right straight through here. So I should be 1, 2, I should be over 2. I should be coming through here. This graph should be coming through that spot. I'm off a little bit here, okay? Yep. Yep, I'm off a little bit in that location. So that's what it should be doing. All right. Then there's another one. I'm going to leave that one for you. This one has no H. There's no H in here, so H is 0. So my vertex is at 0, 2 for this one. So keep that in mind. And is this one narrow or wide? Or is it right side up or upside down? Upward or downward? Which is it? I have a half. It's going to be upward. Wider or narrower? What was it going to be? Wider. Yeah. And then it says the first step in graphing a parabola is to find the vertex. So what's my vertex going to be? Well, my vertex is H, which I don't have. So that's 0. And K. So my vertex is 0, 2. And it says now determine 2 additional points. Now, if you determine 2 additional points, the easiest one to find in this situation is the x-intercept, which I already have, because that's 0, 2, so there's no, or the y-intercept is 0, 2, so I don't have to find that one. So you can just plug in whatever point you want to plug in. So if we put in positive 2, what would the answer be? So 2 squared is 4. 4 times a half is 2. 2 plus 2 is 4. So I found another point. And then if I said, oh, let's see, what does it do at a -2? -2 squared is a positive 4. Half of 4 is 2. 2 plus 2 is also 4. So I found 2 additional points. So it just is plugging in a value when you do those and seeing what you get. And then probably the back page is probably graph it over here. And then they gave me a -2, and they give me 1 in there, finding my 2 points. So we were up at 2 for my vertex. When I was at 2, I was up 4. When I was at a -2, I was up 4. And so this one is kind of doing one of these numbers when I graph it. Okay? So that's where it happens to sit. And 67 I'm going to leave for you to do, because I think you can do the graphing piece of these now. Oh, but that one you got to get in this format, so maybe we better do that one. If I got to get it in this format, how do I get that to look like that? So if I have, this is 67, y equals x squared plus 2x plus 4, how do I get it looking like that? Well, I set it equal to 0. Minus 4. And we're going to complete the square like we were doing, but we're going to move the piece back so we get it in the right format. So half of 2 is 1. 1 squared is 1. Add it to both sides, gives me a negative 3. Move that back over. And now I have it in that correct format, so I can see what it looks like. So I've got my h, which is the opposite. I've got my k, and my a is good old 1 out in front. And so I have it in that, whoops. Oh, yes, thank you. Yep, because I'm going to add 3. Yep, add 3. It'll be a plus 3. Okay, so let's go back to our problem and see what else we got to do in here. It says get it in that format, so we did. We had x plus 1 squared plus 3 equals 0. And then find the vertex. So the vertex is the opposite of h. And the y, or the k. Find the real zeros, so that if I find my real zeros, I want to go back to this point right here and leave it over there. So x plus 1 squared equals negative 3. Take the square root of both sides. So I find out that x plus 1 is equal to plus or minus I, the square root of 3. So it means they're floating, or there isn't any in this case, because as soon as I end up with an I in there, I have no spots where it crosses for my x-intercepts. So I don't have any, so I'd have to say no on this one, or none. So I don't have any real zeros. And so then it says graph the quadratic function. So if I graph it, I need to know where I'm going to start at. So y equals x squared plus 2x plus 4. Plug in a point. So, oh, let's see. Pick a 3. 3x, or 3 squared is 9. 2 times 3 is 6. Plus 4. Can't use it because it's not on my graph. 19 is not on there, so I got to pick something smaller. So let's go with 1. 1 squared is 1. 2 times 1 is 2. Plus 4. 2 plus 1 is 3. Plus 4 is 7. So that point will work. So if I graph my intercept, or my vertex, which is a negative 1 over 3, and that's telling me it's going to cross. So I don't know why I'm getting it that it crosses, because it certainly didn't cross before. Because it's going to cross, because I've got a positive 1 going up here, so it's supposed to cross right in these little spots in here. But I don't know why it's crossing, because I show it doesn't cross. What did they show? Did they show it crossing in the back with your answer sheet? I lost it, why that one did what it did. Oops. $67. Oh, I graphed it wrong. Negative 1, 3 is not there. Negative 1, 3 is up here. Negative 1, 1, 2, 3. There, we're better. Helps if I get my graphing correct. And then if I graph 1 at 7, that goes up there. So this graph is doing something on this order on that side. If I look at my axis of symmetry, I can just reverse this, go over to find my other point on the opposite side, and that happens to be at 3, negative 3, and up 7. And then I'd have my other piece of my graph going through here. So if you use the graphing piece of it to figure out where you got pieces, you can get your flip side point of those and come up with the opposite piece. Okay. All right. Anything else as questions that you have with this part? So that's how far we made it, so we can still go over some of those next time around if you still have questions. And then chapter 11. Last chapter we did, so maybe there's not many questions. I don't know. We'll see. Number 68. What do I do with it? 68 says I want this equation. F of x is equal to 2x squared plus 1. G of x is equal to 2x plus 2. And I want a composition. So I want a fog, f of g of x, which means I want to take g and do what with it? Put it into x. So I'm going to have 2x squared plus 1 is equal to f of x, and g of x is equal to 2x plus 2. So when I substitute this inside of there, I'm going to have 2 times 2x plus 2 squared plus 1. So to finish it out, I need to square this. So if I square it, 2x plus 2 times 2x plus 2. 2x times 2x is 4x squared. 2 times 2 is plus 4x. 2 times 2x is another plus 4x. 2 times 2 is 4. Put them together. So I have 2 times 4x squared plus 8x plus 4 plus 1. Finish it. 2 times 4x is 8x squared. 2 times 8 is 16x. 2 times 4 is 8 plus 1. Or my final answer is 8x squared plus 16x plus 9, because I had to combine it. You all right with that part? I plugged it in, finished it, and then the second piece is to do an O, or a G of O, of F I should say, or a GOF. And so then we're going to take this one and put it into this one. So we have 2 times 2x squared plus 1 plus 2. 2 times 2x is 4x squared. 2 times 1 is 2 plus 2. Or this one happens to be the easier of the two, and I get 4x squared plus 4. Okay, if I do a GOF. All right, so that was that one. And I think you can do 69, correct? Because it's another one just like it. Can I do 70? You guys do 70? It's another one like that. 71. 71 says the following logarithmic equation in terms of variable x. So what do I have? So if I turn this one around, basically it's asking me to put it back into exponential format. So if I do that, remember it's x to the second power is equal to 16. It is asked to turn that into log 2 minus log 2x plus log 2. Alright, so if I have this one, we said this one was a log 7 squared. We agreed it was a division, so we got x in the bottom. Where does this plus go? On the top. Times 31 on the top. And so then that would be my, I guess I can leave it that way or multiply it out. Multiply it out? Okay, so if I multiply it out, I'm going to have 39 times 31. What's that equal? Those again? Okay, all over x. And so that would be the answer. Okay? So we just kind of multiply the whole thing and multiply that would be. What is that? Base squared equals, I don't know that word. Okay, that's 74. You sure? Right. This one? put that other one back up? Yep. I can do that. I kind of whipped it out of there too fast. Slow down a little bit. Whip it out of the way too fast. Okay. Okay. Now we'll continue. This next one is expanded out. So are we good with expanded out? What do you think? Expanded out. 77 is log 3, 5, x to the 6th log. If I expand it, it's going to be log 3, 5 plus 6 log 3 x, and this exponent goes out in front, and finally plus log 3 y. So you just expanded it out and made it into something. We'll go with that. You good with the calculator use? Think so? Okay. Are we good with this next one? It says express the following equations in logarithmic form. So in logarithmic form, remember this is my base 10, and that's my answer, and that's my exponent. So it's going to be log 10, 38.3 is equal to y. Now, because it's a log, I don't really need my 10 in here. So this would really be log 38.3 is equal to y. And I think that in that term, let me look at that. They don't break it down and turn it into the actual answer. So look at that way. This next one, express it in exponential form. So if I do an exponential form, what has to happen? Well, there's a little 10 right there. So I have 10 to the negative second is equal to 1/100. Is that true? Yes? Okay. Good. And then 81 says, solve the following equation for x. We have like bases. So what has to happen if I have like bases? You drop them and you set the two exponents equal to each other. X squared minus 6 is equal to 3. So I add 6 to both sides. And I find out that x squared is equal to 9. Take the square root of each side, and we find x is equal to 3. So you wanted to put negative 3 and positive 3 in the answer, but it's only 3. We don't have negatives and positives. Remember we can't have a negative? If we're dealing with logs, we can't use a negative number if we can't work those things out. Does it? Oh, it does. Yeah, it does. Don't ask me why, but it does have a negative 3. I guess it's because it gets squared right here. Negative 3 times a negative 3 is 9. 9 minus 6 is 3, so it does end up working. That's the reason. And then 82 is like the last one. I think you can do that one, correct? And then this bottom one, we need to do some combining together first here. These two need to get added together. So really I have 3 to the negative 5th is equal to the x plus 2. And so then I need to take this piece and this piece and set them equal to each other and find out that minus 2. I find out negative 7 is equal to x. And does it work? Negative 7 plus 2 is negative 5. I'm sure that they both match each other. So the answer is negative 7. Okay. That is all of that packet for review. Let me put up here again, just so you see it one more time. The exam itself. Now the exam itself has 30 questions. They're broken into themes, so this first part is just general functions. So it's the things like those f of x plus f of g's and that type of stuff that's into this category. Rationalize, this is chapter 7. So chapter 7 is in that spot. Systems of equations is chapter 8. and that's where you use your matrices stuff with it, okay? There's some story problems in that part. Radicals is chapter 9. This one's chapter 10. And the last one is chapter 11. Chapter 10's got that graph in there, and that is a graph of a parabola. So, you got the idea? Think you can do this? I love it now, right? But anyway, that is what your final exam looks like.